It takes many billions of years to create a galaxy like the Milky Way galaxy, with 100 billion stars many billions of years old. But the James Webb Space Telescope has identified 6 galaxies that exist just 500 million years after the Big Bang. Imagine seeing a galaxy that's only 600 million years old, a time when the universe was still in its infancy, long before the Milky Way even existed. Thanks to the power of the James Webb Space Telescope, we can now peer into the distant past, witnessing the birth of galaxies with unparalleled detail. Meet the Firefly Sparkle Galaxy, a cosmic time capsule that's changing everything we know about the early universe. This discovery is especially significant because, despite the galaxy's extreme distance, over 13 billion light-years away, JWST was able to resolve individual star clusters and key structures within the galaxy. This is a rare glimpse into the early universe, a time when galaxies were in their infancy, and the Firefly Sparkle Galaxy provides a look at one of these first-generation systems. For astronomers, observing this galaxy in such detail is like opening a time capsule, revealing how galaxies like the Milky Way might have formed in the early universe. The Firefly Sparkle Galaxy is not just a distant dot on the cosmic map, it's a dynamic, evolving system. Its study offers us insights into the mechanisms that shape galaxies over billions of years. This marks a critical moment in our understanding of the universe's development, as we can observe the processes that led to the formation of the galaxies we see today. Galactic cannibalism and galaxy formation. Now, let's dig into one of the central themes of this discovery, galactic cannibalism. This term refers to the process by which smaller galaxies merge into larger ones over billions of years. Galaxies grow not only by forming stars but also by absorbing smaller galaxies in their vicinity. Just as a larger corporation might absorb smaller companies to expand its reach, larger galaxies pull in smaller ones, contributing their mass, stars, and gas. This process significantly accelerates the growth of a galaxy, triggering bursts of star formation and shaping the galaxy's structure over time. The Firefly Sparkle Galaxy is a perfect example of galactic cannibalism in action. As it evolves, it is currently merging with 2 smaller companion galaxies. This is not an isolated event. Galaxies are constantly on the move, and smaller ones often get caught in the gravitational pull of larger galaxies. These mergers lead to the creation of more massive and complex systems over time. These smaller galaxies contribute their stars and gas, and as the merger progresses, new stars are born, continuing the cycle of cosmic growth. In the case of the Milky Way, we see evidence of galactic cannibalism as well. Our galaxy has grown significantly over billions of years, absorbing smaller galaxies along the way. This process continues even today, with the Milky Way currently in the process of merging with nearby galaxies, including the Sagittarius dwarf galaxy. The discovery of Firefly Sparkle, with its ongoing mergers, helps reinforce the theory that galaxies like the Milky Way grew not just through star formation but through these massive cosmic mergers. How do gravitational lensing and the James Webb Space Telescope allow us to observe distant galaxies in such detail? To capture the Firefly Sparkle Galaxy in such detail, astronomers relied on gravitational lensing. This phenomenon occurs when light from a distant object is bent and magnified by the gravitational pull of a massive object in between, like a galaxy cluster. This acts as a cosmic magnifying glass, allowing us to see distant galaxies that would otherwise be too faint or far away to study in detail. In this case, a massive galaxy cluster called MAX J1149.5 plus 223, located 6.6 billion light-years away, magnified the light from the Firefly Sparkle Galaxy. This lensing effect made the galaxy appear brighter and larger than it would otherwise have been, enabling JWST to capture the intricate details of its structure. The advanced infrared technology of the James Webb Space Telescope then allowed astronomers to observe this distant galaxy, even though it's billions of light-years away and obscured by cosmic dust. The combination of gravitational lensing and JWST's powerful infrared capabilities gave us a level of clarity and detail that would have been impossible with previous telescopes. Without this magnifying effect, Firefly Sparkle would appear as a mere smudge in the vastness of space. But through gravitational lensing, astronomers were able to observe individual star clusters and gas clouds, revealing the galaxy's globular structure, a key feature that suggests the galaxy is still in the process of formation. What is the significance of observing individual star clusters in such a young galaxy, and what does it tell us about galactic formation? The Firefly Sparkle Galaxy offers an invaluable opportunity to study the building blocks of a galaxy, star clusters. By observing the star clusters within the galaxy, astronomers can understand the stages of star formation and learn how galaxies like the Milky Way were built over time. Firefly Sparkle's globular distribution of star clusters, two distinct areas of concentrated clusters, suggests that star formation in this galaxy is occurring in bursts, with some clusters being very young and others much older. The fact that this galaxy is still in the process of forming means that it's experiencing bursts of star formation, a key feature of galaxies in their early stages. These bursts are often triggered by gravitational interactions, and they help drive the growth of galaxies by creating new stars and gas clouds. The clusters that are young and blue are likely the newborn stars that have just started forming, while the redder clusters are older and may represent some of the earliest stars in the galaxy. This pattern of sequential star formation suggests that, rather than forming all at once, galaxies like Firefly Sparkle develop over time through multiple phases of intense star creation. This pattern of star formation also provides insights into how the Milky Way and other galaxies formed. Like Firefly Sparkle, the Milky Way likely started with more rapid star formation in its early stages before slowing down over time. The study of galaxies like Firefly Sparkle helps astronomers understand how massive galaxies grow and evolve, giving us a clearer picture of how galaxies like the Milky Way came to be. Would you like me to continue the analysis?